Hello scholars, Mrs. Kendricks here. I am going to go over prime factorization. This is part of 3-2, but this is kind of part 1. There's actually 3 parts to this section in your packets, and we are going to do one part today. The second part is greatest common factor, and there is a math Zoom meeting on Google Classroom for you to watch if you need to learn about greatest common factor. This is just going to be a short video to help you with prime factorization because they do ask you to do that in part of your homework of 3-2, okay? So prime factorization is very easy. I want you to remember that it really is just a couple steps to be able to find the prime factorization of certain numbers, okay? And you use prime factorization to find greatest common factor and then even LCM, okay? So let's go on and do some examples. So let's say we need to find the prime factorization of something simple like the number 6. You can do prime factorization with any number, any whole number, okay? And I'm going to show you guys just a few examples of how to do them with just some numbers that you're going to see in your homework. So for example, number 6. What we do when we find prime factorization is we make a factor tree. It's called a factor tree because you kind of branch out. And what you do is all you have to do is think, what 2 numbers multiply to make 6? Let's think about that. 2 and 3, right? 2 times 3 is 6. They call it a factor tree. This is called a factor tree because it branches out kind of like a little tree. And then when we do numbers and where there's more factors involved, you're going to see it branches out even more, and we'll get to that in a few seconds. However, when you do prime factorization, you're branching out numbers that multiply to make this number here. So for example, 2 and 3. Now, can I branch out these numbers anymore? Not really. Why? Because 2 and 3 are prime numbers. If I try to branch out 2, the only numbers that multiply to make 2 are 2 and 1. But I'm just repeating myself. So I don't need to do that. That's why we don't factor any prime numbers. This is a prime number and this is a prime number. So the prime factorization of 6 is 2 and 3. If you notice, we put a little multiplication sign in between because we're trying to figure out which 2 numbers multiply to make this number. 2 times 3 equals 6. That is our prime factorization. Again, because we're finding the factors of a number, but we're finding all the prime factors. 2 and 3 are prime numbers. If you need a reminder of what a prime number is, I suggest you look it up. We did go over it in class, I believe, actually for 3-1. We did go over it. If you'd like to watch the beginning of that Zoom meeting, it should be on there. Or you can look it up online. But since we're focusing on prime factorization, I'm just going to show you the steps, okay? So anyways, this is it. This would be our answer. To find the prime factorization of 6, we just figure out 2 times 3 equals 6. These are both prime numbers, so I don't have any more steps to do. And 2 times 3 equals 6. Okay? You can use factor trees for very simple ones, but you can also just, if you can do this in your head, that's also fine. Okay? Now, however, you might be thinking, well, why do I need to do a factor tree if I already know that 2 times 3 equals 6? Let's look at another example. Something that's a little bit more complicated than just the number 6. Let's do something like number 12. Let's find the prime factorization of number 12, of the number 12. So I'm going to start my little factor tree. I'm going to branch out. Well, let me think. What 2 numbers multiply to make 12? You can do 6 and 2, or you can do 3 and 4. I'm going to use 3 and 4. For some reason, that always just comes to my mind. You can use 6 and 2, and you can follow the steps. However, I'm going to use 3 and 4 because 3 times 4 equals 12. Now, you have to double check your numbers. We are not done because 3 is a prime number. If I find two numbers to multiply to make 3, it's just going to be 3 times 1. I'm repeating myself, so I don't need to do that anymore. Once you have a prime number, you are done. 4 is not a prime number. What two numbers multiply to make 4? 2 times 2. Do you see how it starts to branch out further? It does, right? So again, 3 times 4 equals 12, but you must find the factorization of 4 because this is not a prime number. So which numbers multiply to make 4? 2 and 2. Now, can I factor these two numbers? No, because they're prime numbers, okay? I want you to pay attention to something. Do you see a pattern? Do you notice that we work with a lot of 3s and 2s? Just like for the number 6, we have 3 and 2 make 6, right? Well, you're going to start to notice that once you do prime factorization, you're going to usually you're going to have a lot of 3s and 2s. So now that we have done, now again, let me repeat myself, I cannot do any more factorization with these two numbers. These are all prime numbers. So I am done. So I'm going to write that 12, the prime factorization, and this is how you write it. You would write 12 with a little colon here, and then you're going to write all these numbers down. 3, and remember we put a multiplication between them. 3 times 2 times 2. 3 times 2 times 2. This is your prime factorization right here. I'm going to do one more thing though. I'm going to double check my answer, and it only takes a few seconds. I highly suggest that you double check your prime factorization to make sure that you have the correct numbers. How do you do that? You multiply them. 3 times 2 is 6. 6 times 2 is 12, right? So that means I did do it right. If I can multiply my prime factorization and end up with the number that I started with, then I know that I am correct. Okay? Let's do one more example. I'm going to do one that's going to be branch out a little bit more as well. I'm going to do 48. Let's try the number 48. I'm going to start my factor tree. What two numbers multiply to make 48? I'm going to do 4 and 12. 4 times 12 equals 48. Now, let me look at my two numbers though. Let me see if I can continue my factor trees. I can. What two numbers multiply to make 4? 2 and 2. Now let me look at these two numbers. Can I keep going? No, these are prime numbers. 2 is a prime number. I can't branch out anymore. It's just going to keep repeating itself. Okay? Let me look at 12. Let's see. What two numbers multiply to make 12? Well, this time I'm going to use 2 and 6. Is there a certain reason why I'm using 2 and 6? No, I've just decided that 6 times 2 equals 12. You can use whatever two numbers you like as long as they're correct. But let me double check. Can I factorize or do any more branches for the 2 here? No, this one's a prime number. But I can branch out the 6, right? I can do 3 times 2. And these are prime numbers. Again, do you guys see a pattern? 2, 2, 2, 3, and 2. There's going to be a lot of 3s and 2s. If you start to reach those numbers, then you know you're on the right track. So my prime factorization of 48 is going to be, let me write it down, 2 times 2 times 2 times 3 times 2. That should all equal 48. So let me write it down. 2 times 2 times 2 times 3 and times 2. This is my prime factorization of 48. I'm going to double check myself. All I have to do is multiply these numbers and make sure I get 48. So let's try it out. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 2 is 48. So yes, I am correct. So this is my correct prime factorization. Again, we use factor trees because it branches out kind of like a tree. Doesn't it kind of look like a little Christmas tree? It does, right? You can think of those as the decorations if you want. Alrighty, you guys, those are my 3 examples. If you are not quite sure, I suggest to rewind this video and watch it again. Please don't make it harder than what it is. All it is figuring out what 2 numbers multiply. Can I break up these 2 numbers? Can I break up any more numbers? And you are usually, not always, but usually you'll end up with 2's and 3's. Okay? We use prime factorization to find the greatest common factor. Again, that's part 2 of today's lesson, and that is on our Google Classroom under Math Zoom for September 24th, I believe is today. Okay? Alrighty, scholars, this is your example or these are a few examples to help you with your homework. If you guys have any questions, don't forget homework hours at 2 o'clock, or you can email me as well. Okay? Alright, thank you guys. I'll see you next time. Have a good day.